The first talk is a little bit more theoretical, and at the later time today, you will see how the programmable interfaces of PANGAEA are used by PANGAEA R and PANGAEA Pi internally. But for all those who don't want to use PANGAEA Pi or PANGAEA R and maybe, for example, download their data with a simple curl command line call, or from any other application like a custom Python script that wants to download data from PANGAEA or possibly also other data centers, because the approach shown here also works with other data centers, although the formats may be a little bit different. But in general, it gives you the idea, if you have a DUI of a data set, how to access the metadata of that. And for the background about PANGAEA, metadata and data, and for the background about PANGAEA, the first is, yesterday we have seen the landing pages. So Katja explained to you how the metadata is looking like if you are resolving a DUI or a search for it in the PANGAEA search engine. And then in the second step, you get the metadata. But the question is, how can you use that information from software, like a Python script or anything like that? And to understand how the metadata page, as you see it in the web, is generated, you have to know some background about how the metadata is handled in the background by PANGAEA. And this is a really huge graphic. You don't need to remember that forever. I just wanted to quickly show you. So the PANGAEA metadata is stored in a relational database, together also with the data. And whenever a data set is published, the information is marshaled in XML format to some PANGAEA own PANGAEA format, which is then, for example, searchable by the website, and you can see it in the PANGAEA web front end. But the metadata is not only in the proprietary PANGAEA format, it can also be exported in various other formats like scientific people, or especially from the GIS origin, know ISO 19139 metadata, which is the XML schema about ISO 19115. Dublin Core is just citation information. DIF is another metadata format that's quite old already, but still in use for somebody. We are also having DataSite metadata, which is published together with the DUI, and we also have schema.org metadata, which is the most modern type of metadata. And actually, all this metadata can be retrieved from PANGAEA instead of the landing page if you just have the DUI. And how that works, I want to show you in the next few slides. So the trick behind that is link discovery, and the second thing is to actually get the information is content negotiation. So actually a data set consists of several information, which all of them also have persistent identifiers like ORCIDs for authors, licenses have URIs, it is described, for example, by references. We also have the information how the data set needs to be cited. And we have the item and the type of the item, which is actually the data set itself. In PANGAEA's case, it's subdelimited text. So the question is, how do a machine figure out how to get that information? So actually, we are talking about APIs today. Actually, there is no API for that because it's built into the landing pages itself. So actually, this is not only for PANGAEA. This case, you can do the same, for example, for other repositories, and also paper publishers might do that. And it's dictated more or less by the FAIR standard, which tells you that to make a data set fair, it should not be only consumable by humans. It should also be consumable by machines, and for that, the FAIR standard suggests to use HTTP content negotiation. And if you want to figure out what is available by this HTTP content negotiation, there's a standard which is for link discovery, which is signposting, which is created by the community. And nowadays, the newest work is the combination of both, which is content negotiation by so-called profiles, which is in the international gremiums, the W3C is the web working group that defines how HTTP, the protocols, how web browsers work and all that. So actually, how does it work? For example, we have a landing page like that one, and we want to figure out, we see it here as HTML. So the question is, how can we get that information in a different way? So we only have the DOI here, for example, if you're coming from the outside and we want to get that information instead of a non-machine readable HTML page, we want to get it in machine readable form. So the first thing is we want to do a link discovery. And that's possible in two ways. So the landing page has all this information included in machine readable form. So you can tell your Python script or whatever script to extract that information. And there are two possibilities. One is that it's mentioned inside the HTML page, which makes it easy for crawlers like Google to get all that machine readable information. Or the other one is, which is much easier for scripts, is the so-called HTTP link header, which gives you all the representations, not only the landing page, but or, for example, also the download or the metadata in different formats in a machine readable way. So you can do that, for example, by sending, here now you see a little bit of curl request to quickly demonstrate. So we have here the DOI of the dataset, and we are asking it to give us only the HTTP headers. So first is the DOI, we are getting redirected to PANGAEA. And then if you look in the headers, which are available to your Python script or whatever, we get the information of all the other representations of the data set and how to reach them. And one, for example, is if you want to get the data set in text tab separated values, you can, here you can use that link to download that information. And then in a second step, you would go to that link and would download that in that way. That's you can also see that in your browser, if you're looking in your developer console, you see all those headers here. So also your browser knows it, but it doesn't do anything with it. So the second thing is, if you are looking in your browser, the same information is also listed in the HTML. So basically, when you're downloading the landing page, you can just pick the link headers with your script, and then you get all the information like the ICAM scope, which is the downloadable metadata file, which is in that signposting standard, or you get all those metadata formats you have seen before, like LD-JSON, which is schema.org, ISO 19139, and so on. So you can download all that in that way. The other way is if you already know what content type you want to have, because we want to download our data set as tab separated values. We know that before, then it's a one-liner in your Python script or with curl to get a data set as tab separated values. So that's an example here, for example. Here is, we see it how we download it as a text file that works if I have the link already, but if I don't know that URL and just want to get everything as tab separated values, you can simply go to the DOI of a dataset. By the way, it also works with other repositories. It's not only with PANGAEA, and ask the repository to give that dataset DOI in the text tab separated values, and the result is it also downloaded the tab delimited text file that you can then use for working with it with the dataset. And a special trick is also available if you don't know the content type and just want to download it. You can use that magic content type to download the dataset directly from the DOI. So you only need the DOI and that one, and then it will download the dataset. And in the future, it will work possibly with all data centers out there, but not all have yet adapted to that standard. So we can also do the same, like getting the metadata in the ISO 19139, 150 metadata format. If you want to use it for your GIS application, then if you want to see it in a better way, it looks like that. So So in that case, you see here it's standard XML metadata of your dataset. So the second part of my talk is now about how to download the datasets if, for example, you have submitted the data and it's not yet freely available, but for example, the PANGAEA team already have given you access to some datasets because some datasets may be under moratorium. For example, the Mosaic datasets you have seen yesterday in the other example, most of them are still under moratorium, so not everybody is able to download them. So they are somehow password protected in PANGAEA. And the problem is if you have a script, you cannot download them because the script cannot simply hard log in to the PANGAEA web page to get access to the dataset. The script will just get an error message. You cannot download that file. And the correct way for a script to work around that is to get something which is called a bearer token. And with the bearer token, you have then access to all the datasets. And to explain you what a bearer token is actually for, I'll let you give you some information how they're working. So we have here some small monster which wants to get cookies. In your case, it would be a dataset. And the first thing is it tries to get it sends a request to the factory of cookies to get Kekse. So that's HTTP GET request. So I want to have the Kekse. But unfortunately, the repository says, no, you don't have access to those cookies. But I tell you, there's a way to register at the cookie factory and get a token so you can download or get your cookies. So in the next case, the monster is going to the PANGAEA web page. In that case, it would be the authorization server, and would ask with his username and password that he has registered before, and say, here's my username and password. Give me something that I can use as a key to get the cookies from the factory. And that's what happens here. It gives it back a token. And why does it get the token? Why does it not go there and take the username and password to directly contact the factory? The reason for that is, if you have a script like in the PANGAEA sense, and you would hard code your username and password in clear text into that script, everybody who gets hold of your script would be able to download all the data sets on your behavior. And in addition, it would also get your password, which is strictly against the terms of use of PANGAEA, because you are not allowed to share your password with anybody else. And because of that, the trick is here to use something like a token as the key. So you can then, in the next step, send an authorization header, and this token is called a bearer token, which is something in German like a Stellvertreter token or proxy token that identifies you. And then you can use the token as a replacement for your password to get the information. So why is the token better than a password? The reason is you can, as soon as you've figured out that the token, that you have accidentally sent the script to somebody else, you can simply say, no, I want to reject the token, so I delete the token, and then nobody is able anymore and can use your script to download the data. So basically, the token can be deleted, and then the access is gone. So, and finally, the cookie is delivered to our monster. How does it work with PANGAEA? You are registering, you're logging in, and then once you have logged in, you go to your user profile, which is a button here on the top, and then you get here this window with the temporary login token, and you have to copy and paste this token here. It maybe look a little bit different because that's a token I had some time ago. And when you have the token, then you can also download password protected datasets where you have access to. So for example, you could download a dataset from Mosaic, and it would look like that. So you can use the curl, curl here, and you would send this authorization header together with it. So you can also copy that example to you if you want to try it out quickly. But the other thing is, for example, you can also put that token into PANGAEA Pi and PANGAEA R, which you are told about later. So when you are instantiating PANGAEA Pi, you can give the token as a parameter to your script, and then it knows how to download password-protected datasets. So the last part of my talk is a little bit about PANGAEA Search, which was the third part of which was the third part of our meeting yesterday. So you already have seen the syntax of the PANGAEA Search. So how can you access that with APIs? The problem at the moment is PANGAEA is a little bit outdated with its API. We have not yet published a real REST API for machine consumption of the PANGAEA search. We only have something which is called WSDL, which is some older standard of web services. It has not yet ported to new versions. So that's hard to use, and it's about to be replaced. But there's a workaround for that, a simple alternative at the moment, which is not documented by PANGAEA, but for example, PANGAEA Pi and PANGAEA R are using it. And the good thing with that is you can use the same URL parameters from your search window, like here. So, for example, we have searched here for Globigerina bulloides, and we also have filtered by a facet, like we have seen in our talk yesterday. And the trick is now, if you want to make that machine readable, to take that part here of the URL, which is actually the encoding of all that information you have entered here. And then, so this is what the URL looks like here, for example, and we can change the URL a little bit here by inserting that unfortunately undocumented piece of URL into it, and then we get the search results in a little bit more machine readable form. It's not yet fully machine readable. We are working on that, but in the future, this is only for the web page, but this can be used to get the DUIs of the search results. So you can then, for example, in your script, iterate over all of those search results to download them. So the information is, it's not a documented and official API, so it may change all the time. PANGAEA Pi and PANGAEA R are currently using it, but be prepared to update those libraries in case PANGAEA has changed their internal APIs, because we declare that as an internal API, and we are hopefully publishing more modern REST API in the future. So at the moment, you can only do it like I have this described to you. Yeah, so there are also some alternatives. For example, for searching data, you can also use the dataset APIs for searching data, which is already on the REST standard. And the good thing with that is you would not only find data inside PANGAEA, you would find all the data that has a DUI registered, and you get it in a nicely machine readable form back. And then if you want to access the data, you can use content negotiation also with the other data centers if it's possible there. So anybody is invited to write a script that uses the dataset search of DataSite and allows for access not only for PANGAEA, but also for other data centers like Figshare, Zenodo, and all those others out there.